Okay, guys, so just continuing on where we left off. So the last example here for the lesson. This question is asking us to create a box and whisker plot based on the given data, which is the same data as we had in the earlier example. So basically, you have all the data there. We arrange it from lowest to highest, as you can see there, right? It's gone from the low of 15 to the high of 40. So to create our box and whisker plot, as I was mentioning in the previous video, this is what it needs. Well, this is not what it needs to look like, but what we need to figure out are all of these values here, right? We can easily look and find our lowest data point just by looking at whatever the lowest value is. We can figure out our highest data point by looking at whatever the highest value is. These three here in between Q1, Q2, and Q3 are the three we need to figure out using the formula that we went over in the previous part of the lesson. Okay, so let's move on to our example. As I said, here we're going to figure out Q2, Q1, and Q3. Okay, so using the formula that we went over, which was the first formula. So Q2, right, as it tells you here, is also the median, right? The median is represented by the 50th percentile. Okay, so that's why we have a 50 here in the numerator. Okay, so the median is the midpoint of all of the data, so it's the 50th percentile. So using that formula that, again, we talked about earlier in the lesson, 50 over 100 times the number of data points plus 1, and plus 1 here is 26. So that tells us, so remember this is telling us the R value or the rank. So the 50th percentile will be in the 13th rank or the 13th highest value. So to figure out what the actual value of the 13th ranked piece of data is we'd have to start here at the lowest at 15 and then count up to 13. And by counting up to 13, we see that in the 13th spot is 28. So 28 represents the median or Q2, whichever way you want to refer to it. Q2 and the median are the same. Okay. We also need to figure out Q1 and Q3. So what changes in the formula? Well, Q1, as we know, and it tells us in the question here as well, Q1 is the 25th percentile. So your numerator here is 25, representing the 25th percentile. So solving the equation here gives us 6.5. So that tells us that Q1, or the 25th percentile, is located between the 6th and 7th entry. Okay, because our rank is 6.5. So let's find the 6th and 7th entry or data point from starting at the lowest. So we count 1, 2, 3, 4, 5, 6, and 7. Okay, so we find the midpoint of 6 and 7. So the midpoint of 23 and 24 is 23.5. So we know from that then 23.5 is where our 25th percentile will be. And then the last one we got to figure out is Q3, which is also, as it says here, the 75th percentile. So again, same formula, but instead of 50 here for the median and 25 here for Q1, we are going to input 75 to represent the 75th percentile, okay, to figure out Q3. So solving for that, we get 19.5. Again, that tells us where we're going to find the value. 19.5 is not the actual value. So where are we going to find the value? Well, the midpoint between the 19th and 20th entries. So counting from 1 here all the way to 19 and 20. 19th entry is 32. 20th entry is 34. So we figure out the midpoint, 32 plus 34 divided by 2, tells us the value of the 75th percentile is 33. Okay, so now we have all of the information we need for our box and whisker plot. So if I scroll down here a little bit, as I had stated in part 1 of the lesson, we draw our rectangle, and the low end of our rectangle is at Q1. So in this case, we figured out Q1 was 23.5. 23.5. The high end of our rectangle is at Q3, which is 33. So our rectangle here is 23.5, and there is 33. Then we join those two vertical lines to make our rectangle there. And next thing we do is draw a vertical line to represent Q2 or the median. Okay, so again, we figured out the median up here. Median was 28, so I'm going to be somewhere between 25 and 30. So right around there is going to be 28, and then I draw my vertical line in the rectangle to represent Q2. So the box part of the box and whisker plot is done. The whisker part, I guess, or the last bit to do here is plot the lowest value, which is 15, and then from 15 we do a horizontal line connecting to the lower end of our rectangle, and then on the high end our highest value is 40, so we can draw a little, I guess, a small little vertical line or a dash, whatever you want to call it, at 40, and then join that with this horizontal line to the high end of our rectangle. So that would be our box and whisker plot. So anytime you're doing a box and whisker plot, just to review quickly, you'll be able to see your lowest and your highest, right, data points just from the data. So in this case, the 15 and the 40. What you need to solve for is Q1 here, which is the 25th percentile, Q3, which is the 75th percentile, and Q2, which is your median or your 50th percentile. Okay, so there's our box and whisker plot. I don't think it was asking us for outliers, but let's say the question did say, are there any outliers, and we needed to show proof whether there are or there are not. So again, as discussed earlier, to figure out our outliers, we need a couple of things. First off, we need to figure out the interquartile range. Okay, so remember the interquartile range is the range of the middle half of your data. So Q3, which is there, minus Q1. So basically the range represented by that entire rectangle there. So Q3 minus Q1 gives me an interquartile range of 9.5. And then remember to figure out the lower barrier and upper barriers. We do a quick calculation here. So the lower barrier to figure out whether we have outliers or not is we take the Q1 value, okay, which was 23.5, and then subtract 1.5 times the interquartile range of 9.5. So once we do all of that, the lower barrier is 9.25. Okay, so any values that are lower than 9.25, we can now say are outliers. So we can go back up to the data itself and take a look there, right? And we can see there the lowest value is 15, so no outliers. Or we could look right here at our box and whisker plot, and that shows the lowest value of 15. And again, nothing is lower than 9.5, so no outliers on the low end. Then similarly on the high end, we take the Q3 value, which is 33, and add now 1.5 times the interquartile range of 9.5, which gives us a total of 47.25. And again, to see if we have any outliers, you can go back to the actual data, the numbers, or you can look at your box and whisker plot. And we can see here 40 is the highest value that we have in our data. So there's no numbers or no data points above 47.25. So we have no outliers at all. No outliers on the lower end, no outliers on the higher end. Okay, so there is how you would draw your box and whisker plot. And if you were asked about outliers, you'd have to do what we just did here to show whether we have outliers or not. So if we did have numbers below 9.25, then we have an outlier. Or if we had a number above 47.25, then we have an outlier. Okay, in this case, no outliers. And that is it for the lesson. I think the last slide here, yep, is your homework. So there you go. Lesson 6.2 complete. As always, email with any questions, and we'll be back in touch with lesson 6.3. Okay, take care, everybody.